we are going to continue topic 3.2 of implicit differentiation with example 4. In example 4, I notice I have a product rule going on. So I've got x squared and y, and I notice I have another product rule. I've got x and y squared. So we're going to do those separately. So I'm going to take the derivative of x squared, and so which would be 2x dx dx. And then we're going to take the derivative, or keep the y the way it is. Then we're going to add that to the x the way it is, which is x squared. And the derivative of y would be 1 dy dx. And then I've got to subtract from the original problem. And then we're going to take the derivative of the red, which would be 1 dx dx. And then the derivative of, keep the green the way it is. Put a plus sign in between them. Keep the red the way it is. And then take the derivative of the green, which would be 2y dy dx. And then the derivative of x on the right side of the equation would be 1 dx dx. I'm going to write a line to simplify that. So I'm going to get rid of all my dx dx's and any ones that are hanging out. So I have 2xy plus x squared dy dx minus y squared plus 2xy dy dx, I just rearranged it a little bit, equals 1. In purple, I'm going to highlight anything that is dy dx, and then in yellow, I'm going to pick out anything that doesn't have the dy dx. All the yellow is going to go to the right. So I've got x squared dy dx plus 2xy dy dx equals, I've already got the 1 there. I'm going to subtract the 2xy, and I'm going to add the y squared. Again, that could be in any order. I am noticing that I have a dy dx that I can factor out. And even though that isn't the greatest common factor, we've only factored the dy dx out. We don't factor out, say, the x. So I've got x squared plus 2xy equals 1 minus 2xy plus y squared. And then I'm going to divide by whatever is not the dy dx. You get 1 minus 2xy plus y squared over x squared plus 2xy. All right, we're going to do one more. This one has a little bit of trig in it. And I even have a u substitution embedded in it. So I am noticing this piece here is my u. So I'm going to do that kind of off to the side. So u equals xy. And I notice within that, we have a product rule. So I'm going to take that derivative. So y prime equals, the derivative of x would be 1 dx dx. The derivative, or keep the y the way it is, right? Plus, keep the x the way it is. The derivative of the y would be dy dx. If I was to clean that up just a little bit, it would be y plus x dy dx. All right, so now let's do the derivative of the sign here. So the sign would be the sine of u equals x. So when I take the derivative of that, because I just did the rewrite step, derivative of sine is cosine of u equals the derivative of x would be 1 dx dx. And then we have to so I'm going to, what we missed was we have to take the derivative and we have to multiply it by the derivative of the inside. So the derivative of the inside was y plus x dy dx. Then I need to replace my u. So I'm going to replace my u. So we've got y plus x dy dx times the cosine of xy equals, and instead of writing dx dx, I'm just going to write 1. Now, I need to look for anything with the dy dx is going to get boxed in purple. And then anything without the dy dx is going to get boxed in yellow. So it looks like I can for sure move by order of operations the cosine xy by division. So let's start there. So we've got y plus x dy dx equals 1 divided by cosine xy. Then I'm going to subtract the y over, and it's going to start looking weird. So dy dx equals 1 over cosine of xy minus y. Then I am going to divide by the x, which is going to make it look super weird, but that's okay. We're just going to leave the mess. So 1 over cosine of xy minus y all over x.